Okay. So, the continuation is when we're talking about negative exponents. All right. We're trying to get rid of any negative exponent that we see in an exponential expression. We don't like negatives, so we do not want them in our exponential expressions. We're going to complete these tables below, and we're going to look at the pattern that we see. All right, I'm going to do this quickly so that we can move along with this video. It says, first off, if 10 squared is 100, 10 to the 3 is 1,000. Notice with tens, we just add zeros, right, as we keep going. So 10 to the 4th, right, would have 4 zeros, which would be 10,000, right? 10 cubed is 1,000. 10 squared is 100. So 10 to the 1, we know is just 10, right, because it has 1 0. 10 to the 0, we already know anything raised to the 0 exponent is 1, right? So then when we start getting into 10 to the negative 1, it's like, what does that mean, right? That negative 1, I think I've brushed over it before, but anytime we have a negative exponent, it means that we should put that number into the denominator in order to make the exponent positive. So notice how this becomes 1 over 10, and the exponent of the 10 in the denominator is now a positive 1. Okay, and so I'm actually teaching the property. So I already told you what to notice. But this becomes in 10 to the negative 2. We can rewrite it as 1 over 10 to the positive 2. All right, so we've changed the exponent to positive just by writing that number and positive exponent in the denominator. And then 10 to the negative 3 is 1 over 10 to the 3, or 1,000. So notice another way, if I say 1 over 100, that's still 10 to the negative 2. All right, and if all I write is 1 over 10, that's 10 to the negative 1. All right, and we can do that with these others as well, but I've already kind of told you what to notice, so we're going to keep it moving. All right, to get rid of negative exponent, you find what we call the reciprocal, or flip it. All right. Okay, so if we have a to the negative n, we can just rewrite it as 1 over a to the n. Or if we have 1 over a to the negative n where the negative exponent is in the denominator, then we just raise that up to the numerator so that it becomes a to the n over 1. But we know that's just a to the n. All right, let's keep going. So let's say, for example, we have a to the negative 5, right? By what we just said, right? This becomes 1 over a to the n. So this would become 1 over a to the, our n in this situation is 5. N just means the exponent, right? So that's that. We're done with it. So with number 2, we have k to the negative 5 over 5. And our other rule over here says, well, no, same rule. A to the negative n, that means that k to the negative 4 is going to go in the denominator. So this actually will become 1 over 5 k to the 4th. We make that exponent positive by putting it in the denominator. All right. Now, with number 3, we're going over here to this other rule, where this says 1 over a to the negative n. We just put it in the numerator. So that's what we're going to do here. We have 1 over w to the negative 3. And we're going to take that negative 3 and put it in the numerator so that it becomes w to the positive 3. Of course, over 1, but simplified is just w to the 3. All right, so with number 4, we have negative 3 over x to the negative 2. I'm going to give you a second to work this one out. Feel free to pause the video. All right, with number 5, we have 2 over 5 all being raised to the negative 3. We haven't really talked about what to do in this situation, but what we do is we just basically flip the fraction. Because that 2 needs to go in the denominator to make a positive. Actually, let me just work it out because I'm talking. All right, here we go. So basically, we already know to distribute the exponent so that it becomes 2 to the negative 3 over 5 to the negative 3, right? That's by the powers properties that we talked about on Wednesday. But now that we have a negative in the denominator, that needs to go in the numerator. And the negative in the numerator now needs to go in the denominator. So they're basically going to swap places, right, by the rule we just talked about here. Both of them, actually. We're using both rules here. So this becomes 5 to the positive 3. That's how we get that positive exponent. And this becomes 2 to the positive 3. So this is our final. If we want to simplify it, it becomes 125 over 8. If we want to simplify that. And notice that we just end up putting the 5 in the numerator and the 2 in the denominator. Right? So this could also be 5 over 2 to the positive 3. So that's why initially when we were looking at this problem, I said, oh, we just flip the fraction. And it's like, what? Why? Right? So here's why. All right. Number 6. Y'all should know how to do this one, right? Everything 2x y to the negative 5 is being raised to the third power. So we just need to distribute that 3 to each part inside of this parentheses. Try your hand at it. I think you can do it. Pause the video. All right, so this becomes 2 to the third, x to the third, and y to the negative 5 raised to the third. 2 to the third is 8. X cubed is just x cubed. And then we got a power raised to a power, guys. So that's y to the negative 15, right? And then if we just look at this y to the negative 15, we're going to apply our rule we just learned about, the first one. And this y to the negative 15 needs to go in the denominator so that it becomes 1 over y to the 15, right? So we got 8x cubed times 1 over y to the 15, or just 8x cubed over y to the 15. And that's our final answer. All right. So with number 7, we have b to the negative 3, c squared, over d to the negative 5. All right. And I'm going to want you guys to kind of get in this notion that when you see a fraction bar, you need to become friends with it. Okay. Because it's not that bad. What do I mean? Well, we have b to the negative 3, c squared, over d to the negative 5. And basically what we're going to do is just switch up the d to the negative 5 and the b to the negative 3 in order to make the exponents positive. So this c squared is going to be faithful and stay right there because nothing's wrong with it. But that b got to go in the denominator so that the 3 becomes positive. So that's b to the 3 in the denominator. And then d to the negative 5 is going to go right here in the numerator. Well, it becomes d to the 5, right? This is basically us applying those two rules we just learned about. But the simplified way, right? And then our final answer, I'm just going to write this in order, is c squared d to the 5 over b cubed. And we're done. So number 8 should be just as simple, right? This a to the negative 4 is going to go in the denominator. And this c to the negative 5 is going to go in the numerator. All right, so let's go ahead and do that. It becomes negative 3 b to the 7th c to the positive 5 over 21 a squared b to the 7th. Well, yeah, I can still write it here. A to the 4th. All right. So all I didn't simplify anything. I just took the negatives and changed them so that their exponents become positive. All right, now we can start to kind of simplify in all of this. So negative 3 over 21, 3 goes into both of those, so that this becomes negative 1 over 7, right? And then we have b to the 7th over b to the 7th. We already know what happens with that. And then a squared times a to the 4th, product rule, right? So we add those exponents. And then we're just left with c to the 5 up here at the top. So a couple of things need to happen. B to the 7 minus 7 is b to the 0, which is 1. So we can just cancel that out. All right. And we already said that this was the product rule. So this is a to the 6. All right. So our final answer here is negative c to the 5 over 7 a to the 6. Try number 9. That may have seemed a little complicated, but it's not that bad. Try it. All right. This is negative 3. All right. Actually, hold on. Let's go ahead and switch everything up the way we need to. So that x to the negative 2 goes in the denominator. The z to the negative 5 is going to go in the numerator. And so is the y to the negative 3. All right, so negative 3 y times y to the positive 3 times z to the 4 over negative 12 x times x squared, and that's that. All right, take a moment to sit with it if you need to. But all I did was take the expressions with the negative exponents, and those that were in the denominator, I put in the numerator. Those in the numerator, I put in the denominator. All right, so now when we simplify this, negative 3 over negative 12, both negatives definitely going to cancel out. And 3 over 12, 3 goes into both of those, 1 time for 3 and 4 times for 12. So this will become 1 over 4. All right. Here, we need to apply the product rule. So that's y to the 4th. Here, we also need to apply the product rule. So that's x to the 3. So this becomes y to the 4th, z to the 4th. And this becomes x cubed. And so our final answer is y to the 4th, z to the 4th over 4x cubed. And now it's practice time, guys.